Okay, today I'm going to explain you multidimensional item response theory models using the mirt package. Actually, as I said before, in the unidimensional item response theory model, you found that you can use the mirt package for running the unidimensional item response theory models using actually different um, uh, item response models. Uh, in fact, this package supports so many different and modern item response theory models, which not only use for unidimensional item response theory modeling, but also you can employ them for multidimensional item response theory models for either exploratory or confirmatory purposes. In this example, I'm going to talk about an a confirmatory variation of multidimensional item response theory when you uh, mm, faced with a two-dimensional test. This test may be a questionnaire, psychological or educational, or uh, human sciences scales, or maybe a test corrected in a binary manner, 0 for not reaching the true uh, option, or not answering the items, and 1 for choosing the correct response by the examiner. The data set that we are going to talk is the lowest school admission test, the LSAT test that you can see here. Is the test LS87. The data set is actually an item response pattern frequency that you can expand this to a raw data table. So you employ the expand table function. It's a basic function in R that help you to expand your item response patterns. Like here, you have a 5-item scale or chest that corrected in a binary manner. So you have 2 powered by 5 patterns, which yields you 32 patterns, and the last column of this uh, uh, pattern data shows you the frequencies of the examinees that reach to these patterns. So no. The total number of the examinees or respondents is sum of the column of the frequency column, because that means that all the people who missed the correct response are 12, and all of the examinees who answered the 5 items of the test correctly are 308 examinees.
Number 32 was the total number.
No, it's not. It's, as I said, these are response patterns. As I said, these are response patterns. When you have 5 items test that corrected in a binary manner, binary means 0 and 1. So you have two powered by 5 patterns that yields you 32 response patterns here from 0, 0, 0, 0 to 1, 1, 1, 1, and the other scenarios of answering test items are in between. These pattern response data can be converted to raw data table by means of the expand table function here. And if you run this syntax here and call these, actually call the ls87 data to data, we can name it whatever we want here, and it actually make you the raw data table. If you call the raw data here after you converted this to the expand table function, you have actually 1,000 examinees that responded to these 5 test items in a 0 and 1 manner, like this. Okay, so the data is in this case is low school admission test 7. It's a 5 test, 5 items test. You can generalize it to any test or questionnaire that corrected this number. In a confirmatory factor analysis manner using the item response theory models, when a theory is available in your research that relates different test items to different factors, in this case 2 factors, as I said, multidimensional item response theory models are more appropriate for 2-factor models, educational testing or psychological questionnaire or scales. The 2-dimensional tests or scales are well fitted to the multidimensional item response theory model, because when you increase the number of the dimensions in multidimensional item response theories, the number of parameters exponentially increase, and it is very populated with parameters, and the analysis is very cumbersome and may not be converged properly. So I recommend you that you employ the multidimensional item response theory when your test or your scale is a 2-dimensional one. So here, as I said, for this confirmatory item response, multidimensional item response theory, as the other variations of confirmatory factor analysis, you should uh, specify the conceptual model before you running the models. So here we should first specify our model. We name our model the C model. It's actually the confirmatory model for multidimensional item response theory. And uh, we choose two different competing models. Because of different theories, for example, different theories suggest you that you actually you choose one theory among others that recommend you that three of the test items load on one factor and the other two items for the 5 items test load on the other factor. For specifying your model, you may want to use the mirt model function, or without it even you can specify your model. As you can see here, the model may be either specified here like this through the mirt model function, and the other may be specified here, named the C model 2 function, here without the mirt function. However, these two kinds of models may, for example, using the mirt model function may help you to do the better ways of specifying the confirmatory factor analysis modeling items of theory. So we do both models. We first use the mirt function model using the and we name it the C model here. So the C model is actually employs the mirt function model for specifying the models. We say through this function that the item 1, 4, and 5 is loaded on factor 1, that we call it here F1, and the items 2 and 3 are loaded in F2, that is factor 2. And it is in a confirmatory mode of multidimensional item response theory because we specify a model before running the multidimensional item response theory, and actually we set other relationships between factors and items to 0. This is the way that we specify confirmatory factor analysis, and in this case, multidimensional item response theory model. And the other way is not using the mirt model, actually not using the mirt model function. We just specify the related items to the related factors within a column. Note that when you are separating these factors, you should press the shift enter button to separate these two lines. Because when you press enter on your keyboard computer of your computer, actually the model is run. So for separating these lines within the column, these two columns, I mean, okay, for separating these two lines here and here, you should press shift enter to, for example, let me show you here. For example, if you want to uh, uh, put the F2 function below the F1 function, if you run the enter, this actually model is run, so the model is specified. And if I want to separate these lines, we have to press shift and enter to actually put this line below of the first line. So the second model, I name it the C model 2 as written in this example. So we specify two models, one by the mirt model function and the other without the mirt model function. And then we run the model through the mirt function after specifying the C model 2. In the mirt function that we name it here the C mode or confirmatory model for multidimensional item response theory. The data is the data that we explained above, and the C model is actually a two-dimensional model that is confirmatory specified before. And when you don't choose the item type or the item response theory model, the default model is the two-parameter logistic model. So if you run the model, through 125 iterations, the model is converged, and you may want to run the other model. The other model is actually the C model 2 that is specified through the mirt model function here, and the structure of the model is the same as the first model here. It is also run the same way. If you ask for the coefficients of the model yielded here, you must use the COEF function for the C mode. That is the first running model. You can see that a two-dimensional item response theory models ran here in a confirmatory mode. So you can see that the discrimination parameter based on the aforementioned model estimated here for the first item as it is included in the first factor. The item discrimination parameter is estimated here, and for the second factor is actually set to 0. The difficulty measure is also the same for we have actually one difficulty measure that is calculated through the parameter here. So in a confirmatory mode, the item discrimination parameters, whether it is included in the first factor or in the second factor, is estimated here, and the difficulty function is also estimated here based on the confirmatory model that we specified before. For the second model, that is ran here, you have also the same parameters. And as you can see, using the mirt function model or not using the mirt function model make no difference for these two models. This function is actually just shows you are specifying the model, and the other is actually the mirt function is actually removed, and you just specify factor structure here like this. So this is a basic running of the confirmatory confirmatory multidimensional item response theory models. For a default model, as I said, the two-parameter logistic model is actually calculated. You have a difficulty measure and discrimination measure for calculated for the items, and compared with the unidimensional models, we have two discrimination measures according to the factor structure of the model that you specified before. So the items that loaded in an specified factor yields you the discrimination parameters for that item and that dimension, and the other item discrimination parameter is actually set to 0 because it's a confirmatory model. Okay, that's enough for this session. Bye.